Okay, we're gonna record this one more time, this time not using the webcam, and see if it's any better. So first things first, we're gonna open up Workbench. That's going to take just a minute. Okay, so now that we got Workbench open, we want to start a new Fluent project. So we'll just drag and drop Fluent into the project schematic. And we'll go ahead and right click and open a new design model or geometry. You can see down at the bottom right that it's starting design modeler, and that's a good way to keep an eye on what ANSYS is doing and all that. So first thing we'll do is go ahead and change the units to millimeters, and then we'll start on the XY plane and start sketching. First things first, we want to grab a rectangle and just rough it out. From there we can go into dimensions and create two new dimensions, one for length, one for height. We can change these. I'm going to change this a little bit between this iteration. I'm going to make this 1 millimeter in height. And I'm going to make this 150 millimeters and see if that helps our velocity vectors. In the past, I've had some problems with that. So we'll go with that. From there, we can go to concept and make a surface from this sketch. And we can just select one of these planes and hit apply. So now we have a geometry, which we can see by hitting generate. You can see we have a surface. And that's going to be actually it for geometry. So we can run back to Workbench and we can open up our mesh. Just also take a minute, and we can keep eyes on that in the bottom left-hand corner. Down here, you can see it's starting a mesh. Oops. So we'll let that open up. And these first two, geometry and meshing, are kind of the bulk of getting the project set up. And once you've got that done, it kind of goes a little quicker from there. So you can see it just opened up back in geometry. If you come down here, you can see that the meshing is actually open. It just doesn't go right for it. So again, we can come normal to the XY plane. And we can go over here, right click mesh, insert, and insert a new method. From there, we can select our geometry, which is just our rectangle, and apply. We can ensure that that mesh was created properly, because if we zoom in just a little bit, we can see, and also tapping on our mesh. Now we're going to have to zoom out. Interesting. Generally, it should make some divisions there for you, but maybe we'll try generate one more time and let that do its thing. So it says ready. We'll check. There we go. So you can see we've got these divisions here, and that's just letting you know that your mesh is good. So again, we'll right click on mesh, insert, and we'll do some sizing this time. Now we want to go into edge selection up here, and we want to select the top and the bottom. Go ahead and hit apply. Change our type to from element size to number of divisions. And we have 150 millimeters, so I'm going to make this 150 divisions. And we can go ahead and then change capture curvature to no, and change our behavior to soft. Or sorry, change from soft to hard. Okay, and you can go ahead and generate at this point, but I'm going to do the next edge sizing, and then I'll generate it all at the same time. So we can scroll over to now our inlet, and we'll probably have to zoom in just a little bit. Edge selection, we can select that piece of geometry. I'm not sure that it got selected. And then we can pan down to the other side and select the select the last piece of geometry and go ahead and hit apply. Do the same thing here. We change element size to number of divisions. I'm going to make this number of divisions, we'll go 100. And we probably could get away with 10, but I'm going to go 100. So after that, we can change our capture curvature to no and change our behavior to hard. We'll go ahead and generate that all at one time. And that's complete. Now from there, we can go ahead and we can name, well, first actually, if you hit mesh, you can kind of see that you have some sort of crazy geometry going on at the ends. So what we can do here is insert and then face meshing, select the entire rectangle and hit apply. Hit mesh again. Face meshing didn't seem to go all the way through. Let's hit generate. How about that? And if we hit mesh again, we can see that it's kind of looking all black. But if we zoom in a good bit, we can see we've just got a nice amount of divisions. And I did quite a few divisions on this height here. You can get away with less, but okay. The next thing we want to do, or the last thing really we have to do here in the meshing feature, is go to each surface or wall, and you want to name each wall. So this is going to be the top wall. This here is going to be the bottom wall. This here is going to be the outlet. And I spelled that wrong, but it's okay. Scroll down, our last one will be the inlet. And that is pretty much it for the meshing part. You can check that you have all this right, and I can try to rename it. Okay, that's renamed. We can go back over to our workbench, and you can see that this is prompting us to update it. So we'll go ahead and update it. Now that that's updated, we can go into setup. And we can do double precision, and we'll bump this up to maybe hopefully run it a little bit faster. And you kind of just gotta let it do its thing here, let it boot up. You can see the console, it's doing some stuff. And that'll come up, but it is still working. You can see that console is still loading things in. There's our mesh coming in. And looks like we're done, as you can see right here. So go ahead and hit OK. And now we're actually in Fluent. So this is where it starts. You can start changing things. So the first thing we want to do is go kind of from top to bottom here and change our things as we go. So we'll go into models, and we want to change this viscous feature here. We want to change that to laminar because that's what all of our flow cases are going to be today. So we'll change that to laminar, and actually you just want to make sure that all these are off, and then that's actually all that we have to do in this setting. Next is going to be materials. We'll go into fluid, double click that, double click air. We'll have this come up, and just to make everything simple, we can change density to 1, and we'll make this a little bit more viscous. We'll do 10 to the -4th instead of 10 to the -5th. I'll go ahead and change and create that. Close that. That's it for materials. We can go into our boundary conditions. As you can see, we've got all of our named walls here, all right here. So we'll go into inlet. You can see it's already selected as a velocity inlet, and we'll start off with Poiseuille flow, because that's already selected as a velocity inlet. So if we edit here, we can change this to 10 meters per second, or 15 if you're feeling it. Go 15, apply and close. And we just want to make sure that this is a pressure outlet, and we want to make sure that our walls are stationary, because again, this is just Poiseuille flow. So as you can see, we've got a stationary wall. And we'll just ensure that our bottom wall is also stationary. and it is. So that is it for the boundary conditions. Last thing we want to do here is go into reference values. We first of all want to make sure that this is computing from the inlet. And you want to check this every time you change something, because it does have a tendency to default back to this surface body. So make sure it's computing from the inlet. From here you can check that all of your saved features are saved, or if they've registered. So this is our change viscosity, this is our velocity, and our density that we changed, and it's all good. Lastly, from there we can go into initialization and go ahead and initialize. And this will run about 10 iterations. That's done. And finally, we can run calculation. So we'll change this iteration number to about 500. And we'll go ahead and hit calculate. And this part might take a couple seconds, but you can see this chart here is your scaled residuals. This is a good way to know that your program is running and running properly. And it's complete. Go ahead and hit OK. So that is pretty much all we have to do in here, other than if we go into results. Not sure what's happening here, but it looks like we're a little bit frozen. So we'll go into results, and we can add a new vector, and we'll call this our velocity vector. I can't see what I'm showing here. That's our velocity vector, and you can see it's already a vector of velocity. So we go ahead and save and display. Well, probably should hit compute first, and then save and display. Close that out. You can see it's very faint in here, but if we zoom in the right way, we can zoom in, and we've got an interesting looking velocity vector. Try to pan a little bit. This is kind of the problem I've been having with doing 150 times the length. But this looks more like a contour than it does a velocity vector. So let's go ahead and see if we can make a new one. See if that helps at all. Make sure all the settings are correct here. Velocity magnitude. We'll go ahead and compute. It'll show you your min and max right here, actually, which is pretty helpful. And we can save and display. We'll call this velocity vector 1. Well, that's displaying. That's not typically what you'll see, but I'll go ahead and throw in a better looking version in my report. But for now, we're going to move on into post-processing, where we can see our contour. But you should see some lines, some velocity vectors. This is atypical, but I'll go ahead and put an updated version in my, in my report, just for sake of time. So you can see our solution already processed, so we can go ahead into results. And this is going to be our post-processing kind of thing. This is where we're going to see our velocity contour throughout the whole geometry, the whole mesh, and we can also get a chart view of what we're actually looking at. So we'll go normal to the XY plane, and from there we can insert our contour, which we'll call this our velocity contour. Go ahead and hit OK. And locations, we'll do symmetry 2, and it's going to get us our entire thing here. For a number of contours, we'll bump this up to 100 to make it a little smoother, it'll look a little better, and we'll go ahead and apply that. Interesting. So something's definitely wrong here, and we'll go ahead back to, that's why, our pressure. So we want to look at our velocity, basically. This is obviously a velocity contour, so we'll make this velocity U. Everything else is good. So we'll check that out. And there we go. That's what we wanted to see. So this is our Poiseuille flow. As you can see, it's from the legend here. And we'll change that legend to make it a little bit easier to see. So from appearance, we can actually change this from scientific to fixed, which I think is a little easier to read in this case because they're all just the first. And we can also change the location and the orientation. I'll go ahead and apply that, and it's a little easier to see. So as you can see, it's 0 all the way towards the boundary, and then you have this sort of boundary layer going into actually a faster velocity than we've given it. So 15 is our velocity we've given it, which is that yellow region-ish. So that's interesting. And actually, it was kind of interesting to see that pressure gradient get lower and lower and lower as the geometry went on. So anyhow, the next thing we can do is head into chart. Well, before we do that, we need to make some lines where the chart can read from. So we'll go into location and we'll create a line, and we'll call this our midpoint. And we can leave that as all domains. Point 1, since our entire field is 150 millimeters long, we can make this 75 millimeters, and that'll give us our midpoint. And it is important to note that this is in meters, so when you do this, you want to change everything times 10 to the negative third, so you get into millimeters again. And we're 1 millimeter high, so we'll do that. Make that 1 millimeter. Again, we can change our samples to about 100. Make the chart a little smoother, go ahead and apply that. And we'll need one more line. We'll do 2 more because it's interesting to see the inlet. So this will be our endpoint, and for this, it's kind of, if you do like say 150 where it's all the way at the end, you're gonna get some weird artifacts in your chart. So it's better if you go say a millimeter from the end, and that will save you some hassle. Same thing here, 1 millimeter tall. And we'll do the same number of samples. I'll go ahead and apply that. You can see that's our midpoint line there. And this is what we're generating here. We're generating almost a measurement location. So if we actually pan over, again, we can see we're about a millimeter. We could probably go like another 0.5. Get us a little closer to the end. But for whatever reason, if you go all the way to the end, it gives you a strange chart layout. Let's go 9.9. I'll get really close. That's a little better. It's very close to the end and not quite there. So hopefully we won't have any problems. So from where we can go make a new chart, and this is going to be our velocity profile. As you can see, we're taking measurements from top to bottom. So we're going to get that standard velocity profile that we're used to seeing. Go ahead and hit OK. It'll take us over to the chart feature. And you can rename it here, give it a title. And then our important stuff is our data series here. And these are the lines we just created. So we'll call this one midpoint. And we'll make one more. This is the create new button. And we'll make it our endpoint. Location, endpoint, pretty obvious. Next, obviously, we got to change our axes. So on our x-axis, we want velocity, clearly. And on our y-axis, we want our height, so our y. We can go ahead and apply that. And you'll see we get our standard, Poiseuille flow velocity profile. 0 at the edges where it's touching the walls. This confirms our no slip condition. And we get our highest velocity right there in the center. So you can kind of see they're overlaid on top of each other almost perfectly. So the flow has developed fully by the midpoint, and it doesn't change all the way up until that endpoint. And I'm going to prove that by getting rid of the endpoint here for just a minute. And apply. And you can see that's our midpoint. So they're just perfectly overlaid on top of each other. And that indicates we have fully developed flow. It's not changing, so that's good there. That's it for Poiseuille flow. We can go back into Fluent here, and we can go back and start changing our things to get our Couette flow. So again, we want to make sure that everything else is off besides laminar. We are still in laminar flow. And for our materials, it is advantageous to make this a little bit more viscous. So we'll go 0.01, and we'll change create. and close. That's going to be it again for materials. Lastly, we got to change our boundary conditions. This is going to be the last kind of change we make to our actual model before running it. So we can go ahead and double click this, and then I'll get us all of them. Our inlet is going to move from a velocity inlet to a pressure inlet. And it'll come up with a window here. And obviously our pressure is going to be 0. We don't have a pressure gradient, so we'll just say apply and OK. And the only thing else here we're going to change is now our top wall is going to be moving. And that's indicative of our Couette flow. So we can, I think I did 15 last time. So we'll do 15 on this top wall again. Apply and close. And our outlet still a pressure outlet, bottom wall still not moving. That's it for that. Now, again, I want to say you check this reference value because you'll see it defaults back to surface body. And we want to change that to compute from the inlet. So we can check here, make sure everything's good and saved. Turn my ringer off. Our viscosity is updated, our density is still the same, and our velocity is 0 for our inlet velocity. So from there, we can actually just go ahead and initialize and calculate because our iterations are already set up for run. So we'll initialize and calculate at the same time. And if we click over to our scaled residuals, we can watch this kind of update after the initialization process is done. And you'll see it'll start to update in real time. And done. So similar problem here, and not entirely sure how to fix this on the fly, but it's showing that that vector is created. And it says it's in the style of 3D arrow. But as you can see, we're still getting that. Basically just the same thing we're getting from the contour, just section-wise. So yeah, again, I'll include this in my report when I get a little bit more information on this. This is the first time this has happened to me, so I'm not entirely sure. Usually it works pretty well, but yeah. So again, we can go back to our workbench and update our results. And what this is going to do is put in our information, all those changes we just made. That's going to update that on the post-result process, post-result side of things. So that's all done. You can head into post, and you can see it already updated our chart here. And we have nice clear Couette flow here. So we can also head back into our 3D viewer, and looking at our velocity contour here, you can clearly tell that, we have 0, no slip condition here, all the way up to just about 15 meters per second. I'm assuming if we extended this out a little bit, you'd see 15 meters per second on this wall. And that's our, that's our gradient going down. It's typical of Couette flow. As you can see here, that's our velocity profile. So from there, if we want to combine these, we can head back over to Fluent and change our density back, or sorry, not our density, our viscosity back to that lower viscosity of 10 to the negative fourth. Change create. And that's going to help us with our Poiseuille flow. So from there we can change our boundary conditions. We want to actually leave our top wall at a moving top wall. The only thing we're going to change is our inlet, and that's going to change back to velocity inlet. It'll come up with your window here, and it should have saved our previous data from 15 meters per second. So we'll go ahead and leave that as it is, apply and close, and we'll check our reference values again. As you can see, it defaulted back again, so we'll change that back to inlet, and you can see our viscosity came through, and everything else looks good. So we'll go ahead and initialize and calculate again. We can check our residuals in real time once this goes through. A little late, but same problem here. Don't know what this button does. So we'll fix that later on. I'm not sure. Anyway, we will go back to our workbench. We'll update these results one last time. You can see down here it's working. It's updating the results. And it's updated. So we'll head into post. And you can see we have a nice velocity profile indicative of combined flows. This is right here. Obviously, this is our 15 meters per second. That's our wall moving on top. And then this is our incoming velocity. And I think another interesting thing to do here, we'll go back into 3D Viewer. And we'll make one more line at the inlet. We'll call it inlet measurement. And we'll set this to 1 millimeter. And 1 millimeter here. 100 samples, apply, and we'll go back into our chart viewer, add this as one of our new data series, and it's pretty interesting to see because we have some Poiseuille flows starting, but you can see it's not fully developed yet, so it takes a little bit of time to develop that. You can also check out our velocity contour and go all the way to the beginning. And you can see, like here, it's definitely not developed. This is just your incoming 15 meters per second velocity, and obviously that's not going to change because our wall is the same velocity, but you can see this stays around 15 meters per second, obviously, because our top wall is moving, and we have our no slip condition down here at 0 meters per second. So that's going to be it for the first project in Fluent, and that's all of our stuff. So yeah, that's it. Thank you guys.